Hi everyone, greetings from VNR JYOTHI Institute of Engineering and Technology. This is by Manohar Reddy, Department of Cybersecurity, Data Science and AIDS. In this session, we are continuing with the concept of frame allocation method, which was we discussed in the previous session. So in this continuation of allocation of frames, next allocation method is what? Proportional allocation. So this method allocates frames based on the relative size of each and every process to ensure larger processes have more space. That means larger processes can have more space and lower processes can have small sizes. So based on the relative size of each and every process will be allocated for the each and every frames. So frames are allocated based on process size. So if any higher order process size, if any higher size of the process can have the frames are allocated for number of frames, and lower order of the process can allocate minimum number of frames. So here the larger process receives more frames. Larger process receives more frames. So here the formula is what? To calculate the frames for each and every process based on the process size is frames equals to size of the process divided by total size into total frames. Here the size of the process P1 divided by total size of all the processes, total size of all processes into total number of frames, into total number of frames. So this entire proportional allocation is depending upon the process size, depending upon the process size. The process size is depending two types. One is higher order process size. One is higher order process size. Second one is lower order process size. Lower order process size. That means if suppose 50 kb of the process is there, if it is high, then the number of frames required for this process is more. Number of frames are required for this process is more. If suppose 10 kb of the process size is there, that means the 10 kb is less than this 40 kb. So the number of frames are required for this process is less. Number of frames are required for this process is less. That is the point we are going to remember here. These frames are allocated in this proportional allocation. Frames are allocated based on the process size. Higher order process size will be require more frames. Lower order process size requires less frames. So like that we can think each and every frames are allocated. So here the frames are given based on the process size. So let us take an example. There are 3 processes are available, and for each and every process size, for process P1 10 kb of the size, for process P2 20 kb of the size, for process P3 30 kb of the size. So we have to calculate the formula. What is the formula? Frames equals to. So that means to find the number of frames for each and every process. So here the 10 is the size for P1. So how many number of frames are available? How many number of frames are going to allocate for this P1? How many number of frames are required to allocate this P1? Similarly for the P2 size is 20, which is greater than the P1. So how many number of frames are allocated? How many number of frames are required for this P2? How many number of frames are required for this P2? Because it is a higher size, higher order size than the P1. And similarly P3 is having the 30 kb of the size, and which is higher than the both P1 and P2. So it requires more number of frames. But how many frames that are exactly required for each and every process, that we need to calculate. So how we are going to calculate? So to calculate the number of frames required for each and every process is the frames equals to size divided by total size into total frame. So size is nothing but what? Size of the process. If we are talking about P1, for P1 that size is what? 10 kb of the size divided by total size is what? 60 into total number of frames. Total number of frames are 12. That is given in the problem. So total number of frames are 12. So how we are going to calculate? So 12 into 5 into 2. So that means 2 frames are available for P1. The only thing is we have to consider the less size process having lower number of frames and high size of process having more number of frames. So that means lower size of the process can have minimum number of frames and higher size of the process can have more number of frames. That is the thing we have to remember. So now for this process P1 we required 2 frames and we'll go for the P2 also. So for the P2, that size of the P2 is what? 20 divided by total size is what? 60 into the total frames equals 12. So how much? 12 into 5, 5 into 4. So total 4 number of frames are available for P2. So total 4 number of frames are available. 4 number of frames are allocated for each P2. And similarly for P3. So for P3, what is the size of P3? 30 divided by total size is what? 60 into total number of frames. Total number of frames are 12. So 12 into 5, 5 into 6. That is 6 frames are available. 6 frames are ready to allocate. So for P1, 2 frames are allocated. For P2, 4 frames are allocated. For P3, 6 frames are allocated. So as per this proportional allocation method, if any process having more size, then it requires more number of frames. So because of this problem, P3 having the higher size than this P1 and P2, it requires more number of frames. That is why the more number of frames are 6 it is going to allocate. And the second one P2 is 20, which is less than the P3 and higher than the P1. So it requires 4 frames. Compared with both P1 and P3. And similarly for P1, size is what? 10. And because of that less size than P2 and P3, it requires only less number of frames. So here P1 is require 2 allocation frames and P2 is requiring 4 allocation frames. P3 is requiring for 6 allocation frames. And here you can see another example from this. What we understand, the bigger process require more frames. So P1, 2 frames are required. For P2, 4 frames are required. For P3, 6 frames are required. So as per this discussion, as per this problem, we have to write this number of frames are required for each and every process. So for P1, it requires only 2 frames. Or for P2, it requires only 4 frames. And for P3, it requires only 6 frames. So this is the proportional frame allocation method. So how many number of frames are available? 12. And total size of the process is what? 60. And how they are going to be allocated? So here process P1, 2 frames are allocated. For process P2, 4 frames to be allocated. And for process P3, 6 frames to be allocated. So how they are allocating in the entire total frames? 12. So first 2 frames P1 process 1 allocated. The next 4 frames P2 4 frames are allocated. And next 6 P3 6 frames are allocated for P3 process. So like that, the memory frame will have the view of all frames are allocated P1, P2, P3 into the memory unit. Let us take an example, one more example. If we have total number of frames are 10 and the process sizes are P1, P2, P3. That means P1 15 size, P2 25 size, P3 35 size. Then how we are going to find the number of frames? So find number of frames for each and every process. So how we are going to calculate? So to calculate that one, what is the formula first? The frames equals to size divided by total number of process size into frames. So total size divided by total number of process into number of frames. Now see here, for first P1, the size equals to 15 divided by total number of size. Total amount of size is what? 35 plus 25 plus 15. That is 75 into frames. Total number of frames are nothing but 10. Right. So how we are going to calculate for each and every one? So 15 into 5, 75 and 5 into 2. So for P1, 2 frames are available, 2 frames are allocated. So this is the formula, frames equal to size by total size into total frames. So for P1, it allocates only 2 processes. For P2, what is the thing? 25 divided by 75 into 10, 10 frames. So 25 into 3 times, then next 3 into 3 times. So total number of frames are required 3. And similarly for P3, the size is what? 35 divided by 75 into 10. So 5 into 2, 5 into 15. Then next similarly 5 into 3, 5 into 7. So total 14 divided by 3, that equals to nearly 4 point something, that means 4 number of frames. So as per this calculation, P1 requires 2 processes, 2 frames, and P2 allocates 3 frames, and P3 allocates 4 frames. Let us see here. The first P1 we have to calculate 15 divided by 75 into 10, that equals to 2 frames. And for P2, 25 divided by 75 into 10, that is 3.33, that is nothing but we'll take only integer part, so 3 are the frames. And similarly for P3, 35 divided by 75 into 10, that is 4.66, that is integer part 4. So we will consider for P3 4 frames. So final allocation is what? The P1 is 2 frames, and the P2 is 3 frames, and the P3 is 4 frames. That means 2 frames are allocated for P1 process, and 3 frames are allocated for P2 process, and 4 frames are allocated for P3 process. These frames are allocated for each and every process based on their sizes. So what is the size of P1? 15. What is the size of P2? 25. What is the size of P3? 35. So based on these sizes, we are calculated the each and every number of frames for each and every process. So as per this connection, we are calculating total number of allocated are 9, and the remaining 1 frame is empty. So this is the way we are calculating each and every frames for the each and every process. The comparisons of all the frame allocation methods. So how we are going to allocate? So the minimum number of frames are allocated for each and every process is, we are giving either 2 or either 3 or either 4, whatever it may be. Out of all the frame numbers, out of all the frames, we are allocating minimum number of frames for each and every process. And in the equal allocation, we are dividing the total number of frames into equally sized frames. So here the minimum allocation. So the definition is what? Minimum allocation. Each process gets at least minimum required frames. So that means minimum number is taken from the overall frames. Suppose if I have the total number of frames is 10 and processes are 3, then we are saying that what? Minimum number of frames for each and every process is 3. Then each process, P1 having 3, P2 having 3, P3 having 3, and the remaining 1 frame is empty. Like that, we are allocating the minimum required frames. And in the equal allocation, frames are divided equally among processes. All the processes. And proportional allocation, frames are given based on process size. So based on process size, we already said that what? Higher order process size is taking more number of frames, and lower order process size is taking less number of frames. So that is why frames are given based on process size. And what is the formula? How we are going to calculate? So frames equals to minimum required per process. So how many number of frames are required minimum for each and every process? That is the frames equal to minimum number of minimum required processes. And for equal allocation, frames equals to total frames divided by number of processes. Suppose total frames are 10 divided by number of frames are 4, then we are saying that what? 2.5 or 9 by 3, then we are saying that what? 3 frames for each and every process. And similarly for proportional allocation, to calculate this frames equals to size by total size into total frames. So this is the proportional allocation formula. And allocation type, fixed minimum and equal distribution. How we are going to allocating them in the form of type? So fixed minimum and equal distribution and size based distribution. Size wise we can allocate number of processes to each and every number of frames. And remaining frames, if we have any minimum number of frames are left, then it may remain unused. And in the equally allocation, usually may not be unavailable, because we are distributing equally equal frames to each and every process, so may not be available any free frames. And for proportional allocation, many remaining due to rounding, And the complexity of allocations, minimum allocation is in simple way to allocate, each and every one is allocated simply. And the equal allocation is also very simple, because we are just dividing them each and every one. And the proportional allocation is slightly complex or difficult than these two allocation methods, minimum and equal allocation methods. And efficiency, it is not efficiency if process differ in size, different size. And equal allocation not efficient if process different in size also. Same remark for both minimum allocation as well as equal allocation, the efficiency. And proportional allocation is for more efficient than these two allocation methods. So this is the way we are going to compare each and every frame allocation methods based on their minimum number of frames are required and equally distributed frames are required, or the frames are allocated based on the process size. These are the different comparisons of frame allocation methods. I hope all of you understand all about these topics. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.